So this is pre-algebra, so welcome to pre-algebra, guys. I'm just gonna go ahead and get started as we always do on our supplement first, and then we'll go into our lessons. So you obviously can't ask questions here, so ask your parents for the info on the tutor session on Friday, but you guys can ask any questions there and join in. And I don't think there's anything else that I would say. Just if you have any questions, definitely just send me an email or put anything on Google Classroom. So I'm going to go straight to our whiteboard and turn my video off here. Okay, so go to video, or our whiteboard actually. My port here, make sure you can hear me. Okay, there we go. So we're going over a little bit of review in week 19. So if you have the supplement, we're starting week 19. So here, actually I'm going to change my color here. Go back to blue. I think blue's probably the most visible here. So we talked about these equations before, right? There's equations that are true, false, or conditional. So the details for each one of these, right? So we can have true equations, and there'd be something as simple as 5 plus 8 is equal to 3 plus 9. Because then if we add these, right, we know that this is 13. Right, I wrote the wrong one. I had it on my screen here. This is 4 right here. So let me eraser here. Okay, so if this is 4 here, then this would be 13, right? So that'd be a true equation. And then if we had a false equation, it'd be what I first wrote there, where I didn't transcribe my notes here. So if I had 2 plus minus 3, we're going to review negative numbers a little bit more as well. If I had 2 plus minus 3 is equal to 5. Well, if I add a negative number to 2, then I have to take it away, right? So then I'd have minus 1 is equal to 5. And then obviously be false. Now, the other option that I can have is a conditional equation. Right, so if I have a conditional equation, it's dependent on a value equaling something. So if I had something like 2x minus 5, and if we go back and remember what this 2x means, right? There's a little multiplication sign in the middle here. I was trying to show it to you guys here with the dot here, right? There's a multiplication sign that's in between these, so it means 2 times the value of x minus 5, and then if I had it equal to 15, then in order to figure out what that is, right, if I had a value here for x, right, then I could say if x is equal to a certain value, right? And in this case, you guys can probably see if my x value was 10, then I'd have 2 times 10, and that would be 20. So let's do this. So if I said x is equal to 10, then I'd have 2 times 10, so I'd have 20 here, right? Nope, that's not working out very well. Okay, so let's go back to drawing here. So I have 20 here, right? And I'd have minus 5, and that would equal to 15. So that's what it means by conditional, right? So the first section of your practice is just to label whether your equation is true, false, or conditional. And then the second part is they're giving you, so 4, 5, and 6, they're giving you a value here, right? So let's go to a new pad here. If we had something given to us, right? So if we had x minus 4 is equal to 6, and then I could say, does that, and then I could say x equals 8, right? So if I said x equals 8, then you guys would know that you just put in 8 over here, right? So put 8 in for this value right here. Then I have 8 minus 4, and then I'd have equal to 6 over here. And unfortunately, what we'd see, right, that this is 4 equals 6, so that is not true. So then in that case, for 4, 5, and 6, then you would say that no, it does not satisfy that equation. And then the last part of the supplement has to do with solving equations, right? So 7 through 15. So let's go back here, and I'll just say if you guys need to pause the video at any point and review it, you can do that. But let's look at the last part here. So it says using the opposite operation, right? So if I had something like this, right? 5x plus 10 is equal to 30. And the opposite operation, right? So if I have 5x, and again, 5x, remember, right? 5x means that we're doing 5 times x, right? So that's multiplication, plus the value of 10 is equal to 30. So I don't know the value x, so I can't add these things up on the left side. But if I want to get rid of my 10 here, right? Then how do I get rid of that? We've talked about it before, right? If it's there, then I just would subtract it and it'd be gone. But we have to be fair to the equation. We have to say we're going to subtract 10 from this side, right? We can add these up. And so then on the left side here, right, we can cross out our 10s. We don't have those anymore. And then we still have 5x here, so 5 times x. And then over here, we have 20. So then if we're going to do the opposite operation again, so right, we got rid of 10 by doing the opposite of plus 10, which is minus 10. So right here, we have 5, and we have a multiplication sign here. So it's 5 times x is equal to 20. The opposite of multiplying this value x, right? If the opposite of multiplying that by 5 is dividing by 5. So if the opposite of that, of multiplying by 5 is dividing by 5, we can go ahead and, whoops. Right, so we go back here, then we do the opposite, right? So we divide by 5. And if we divide by 5, then we just get 1x. So we always want, right? We say we want one of our variable. Right? So whatever our variable is, in this case, it's x. We might use y in the place of it, or we might use a or c. Right? You guys will see this in your supplement. There's different letters, but they all represent just a number that we don't know yet. So anyway, I did the opposite operation, right? And I want one of our variables. So if I divide any number by itself, it's going to be 1, right? So if I have 5 times a number, I can divide it by 5, and it will become 1. But I always have to do the same thing on the other side. So do that. And so then on this left side, right, I'm just left with x, or I could even say 1x like that, right? So 1 times x, and then it's equal to this division right here. So 20 over 5. So you might say 20 over 5 is a fraction, right? But that means 20 divided by 5. And so then I'd have 4. So then my final answer here would be 1x is equal to 4, or you could just say x is equal to 4, right? So that's how you do a simple one like this. Now maybe there's, you think of being a little bit more complicated. So let's go back and we'll open one more of these. So let's plus here. So if you had something where you actually had 2x plus 2 over here, and then let's say you had, I don't know, well, let's say we have 3x over here, and then you have plus, let's see, we could do, okay. So then in this case, doing the opposite operation is a little bit trickier, right? Because you think, well, which one do I do, right? Because you might be tempted to say, oh, I'm going to take away 2 from both sides and take away 10 from both sides, but that would basically cancel each other out. So now this is the time to assign a variable side and a constant side. So if I can do it either way. Usually the easiest way is to assign this left side as variables. Right, so I can say variables are over here, and then constants. So as we learn, constants are just numbers, right? So if I have, oops, my pen doesn't always want to draw. So I want variables on my left side and my constant on that side. So I can draw a line here, right? So that's where I want it. So if I want my variables on this side and my constant on the other side, my left side has a variable and it has a constant. So I want to get rid of my constants. Let's go ahead and do that. So let's subtract 2, and we'll subtract 2 from this side as well. Okay, and then I would also like to get rid of my variables that are on the right side, right? So I have 3x over there, and I have 2x on my left side. So I can go ahead and subtract 3x here, right? So I'm still doing the opposite operation. And then I'll do minus 3x. Now this is a little bit of a complicated example, right? Because it looks we're subtracting more than we have on the left side. So let's talk about that for a second. So my numbers are fine, right? So I can cross those out, right? If I have minus 2, I have plus 2 and minus 2, they cancel. If I have 3x and I have minus 3x, then that cancels. Okay, so that's good. So I can see that I have all my variables on the left side, all my constants on the right side. For my variables, I have 2x minus 3x. So just like if I had $2, right? So just say I had $2 and I took $3 away from myself, but say it's in the bank, then they'd say I owed $1, right? So then if I borrowed money, right? So then if I did 2 minus 3x, then have minus x, okay? So I'd have minus x, and then on this side, I'd have equals, right? And then on this side, I have 8. So like I said, this example, I don't know that you're going to see this in your supplement, but it's good practice, right? So if I have minus a number is equal to 8, then right, maybe you can see already that my 1, right? So I always want 1, and that if I switch this around, then my x value will actually be minus 8. Well, let's go ahead and do the opposite operation that we've learned here. So this right here, it's a minus sign, but I could just say I have minus 1x. So I could actually write it like this. But usually, right, if you have 1 of something, you don't ever tell anybody you have 1 of something. You don't say, I have 1 of this. You just say, I have $1 or something, right? So minus 1. So if we want to do the opposite operation here, any number divided by itself is 1, right? So I can divide by -1 here, and I'll divide 8 by -1 as well. So then if I divide on this left side, right, these cancel right here, right? -1 divided by -1 would just be 1. So then I just have x. And then on this side, if I do 8 divided by -1, then that just gets me -8, okay? So that would be an example of where you do the opposite operations for both sides here, where you want to label, right, your left side, your right side as variables or constants, and then do the opposite operations until you just have variable on one side and constants on the other side. Okay, so at this point, I'll say just go ahead and if you want to pause your video, and then I'll move on to the next lesson. So you guys pause this video, work on your supplement for a few minutes, and then I'm going to move on to the next lesson. Okay. All right, so let's go ahead and move on to lesson 69. So lesson 69 here, up here. So lesson 69, book we have absolute value, which I guess I'll go back here. So I'll have absolute, spell it out here. Not very good at drawing with my pad here, but it'll have to do. So absolute value and adding signed numbers, right? So we reviewed this a little bit earlier in the year, but it's always good to review it again. So adding signed numbers. Our absolute value just simply means how far, right? So we're going to define absolute value and just say how far a number is from 0. Okay. And 0, we let's put like a 0 through it to distinguish it from an O. Okay, so that's absolute value here. Okay, and then we'll add sign numbers. So if I'm going to talk about absolute value real quick, right? Then if I had these symbol bars right here, that means absolute value. So if I put -9 in here, then if I asked you how far it is from 0, then you might say -9, or you might be tempted to think that. But it's just how far it is, right? So it's 9 away. Okay, so similarly, if I had, +9, and I said the absolute value of that, then it would just be 9 as well. Okay, so you guys have already seen absolute value before, but that's just a little bit of review there. Okay, so let's go and talk about, still we're on lesson 69 here, so I'll keep 69 up in the corner so you guys can keep track of that. But for adding signed numbers, so adding signed numbers. We can add them on a number line, right? So if we're adding them on a number line, we'll just say on a number line. And then put a couple steps here. So first step, I just say make a circle at the first number. Okay, so make a circle. At the first number. And then you're going to move using the, I could say the second number, but move using the next number, okay? If you need to add more than one, add the next number or numbers. And then the final thing, right? Where you stopped is the answer. So where you stop is the answer. Okay, and I guess we're running out of space here because my pointer is not real big. Anyway, so where you stop is the answer. Okay. So then if I open a little tab here, so this is still 69. But if I was to write -5 plus 7 on a number line, okay, so this is a number line. So then I want to start with -5 and plus 7. So first I want to make sure that I can write -5 on here. So make your number line to make sense with the numbers you have. So we know that if we have -5, we're adding to it, right? So we could start maybe -5 down here. So we could label this -5. Maybe we'll do a couple tick marks here. So -4, -3, -2, -1. Maybe we'll put 0 here. Okay, and we'll start doing a couple of these. So we'd start at -5, so maybe make a little circle or dot there. And then if we remember our steps, right? Our other step was to move using the next number, right? So our next number is 7, right? So we're going to add 7. So then we just go over here, 1, 2, 3, 4, 5, right? So 5 will get back to 0. We have 6, 7, right? And we can say 7. So then we have 2, right? So in this case, it's pretty simple because we just move there. And then if we're not going to use a number line, okay, so I go back here, we'll create another whiteboard. So we're just using procedures. Using procedures, right? Then we have two cases, right? So we'd say, actually, let me go back one. So say if signs are the same, right? So if they're both positive or they're both negative, the signs are the same, then we can just add whatever values we have, right? So add values. And then we just say keep the sign, right? So keep sign that both numbers have, right? Now, if the signs are different, right? And it changes things a little bit, right? So then we just say if we just have one negative, one positive number, then we're going to subtract whatever number we have, or numbers we have. So we'll subtract our numbers here. And subtract values, and actually say subtract absolute values. Right, so take the absolute value of both the numbers there. So then we'll show an example here in just a second, and then for the sign afterwards, right? So for the first one, we kept the sign the same. So then for this one, we'd actually keep the sign, but we have to keep the sign of, oh, let me go back here. So keep the sign My eyes don't turn out very well sometimes. Okay, so keep sign from largest absolute value. Okay. Hopefully you can read that there. Okay, so keep it from the sign from the largest absolute value. So if I show an example of this, right, where we're just doing a procedure, right, that we're not using number line this time. If we have really big numbers, it just isn't practical to use a number line. The number line is the helpful way to think of it, though. So if we're going to say -8, and then we said plus -17, then this would correspond to that first case, right? So we can notice that this first one has a sign that's negative, right? So this is negative, and then this one's negative as well. So another way of writing this equation, or not equation, but of this expression here, right? You can write -8 -17 if you want to. That's the same thing as what I wrote on the top line. So the second step, right? So or the first step, if the signs are the same, is to add the values together, right? And then so we can add the values, or the absolute values, really, right? So we'd add 8 and 17. So if we're going to add 8 and 17, right, we probably don't need to set them up like this. We know what that is in our head, but we can go ahead and do it if you want to, right? So this would be 5, and have a 1 over here, so we have 25. All right, so now we're on to our next step. So we said, right, that our right here, you see on the left here, right, it says keep the sign, right? So keep the sign. So our sign from the previous step was minus, right? And so that makes sense, right? Because both of these numbers are already negative. So if we're just adding negative numbers together, then we would expect to have a negative number at the end. So let's look at a quick example where the signs are going to be different, right? So if I have 4, and then it says minus, and I don't know, I'll just do -4, right? Then we're just going to subtract these. This is a really simple example, but since our signs are different, we're just going to subtract the absolute values of these, right? So I'll just do 4 minus 4, and that's going to be 0. Now, if I did something a little bit more complicated here, right? So if I did, let's just say I did minus 53 plus 25, okay? If I did minus 53 plus 25, then if I'm going to subtract these, I can't do 25 minus 53, right? I'm doing the absolute values. Then I'd have to do 53. Oops, 53. I have to do minus 25. And so then I can't do 3 minus 5 either, so I have to borrow from the 5. So I have a 4. And then I'll have 8 for this column here. I have 2 here, so I'll have 28. Okay, so I have 28. And now, how did I determine whether it's a positive or a negative? Well, I keep this sign from the largest absolute value, right? So which number is farthest from 0, right? And we'd say that it had to be this first number here, right? So regardless of whether it's negative or positive, we just want to know how far it is away from 0. And since it's farther away from 0, then we have to keep our negative here. And this makes sense, right? So if I already have something that's way more negative, then the final answer is going to be negative. All right, so that's all I have for lesson 69, right? So this is 69. So if you want to pause the video now, work on your practice problems, make sure they make sense, and then you can start the video when you're ready after that. Okay, so then we go to lesson 70 here. Right now we have more rules for adding signed numbers. So these are for rules for more than one or two or more than two numbers, right? So rules for adding signed numbers. Okay. So we can always add left to right. So I'll put that here, right? So we can always add left to right. Right. Okay, so there's nothing wrong with that, but you're just adding one number at a time. If you had more numbers, right, and you want a couple things to remember here. So we can add all the negative numbers we have. So add all negatives. And then that will give us a negative number, right? So then we'll just add all of our positives. And then we'll just use our other rule, right? So then we'll just add our sums, right? So add our two sums. So if we had an example that's already outlined here, right? We have example 1, we have -4, we have +3, and we have plus -5, and then we have +7. Okay, so I told you before, right? You can think of this over here, right? So we could think of this instead. We could think of it as -4 + 3. Oops, let me say 3. We could think of this as -5. Maybe this is +7. So we don't have to write plus -5 here. We can just think of it this way, right? So it looks like we have two negatives and two positives, right? So we can add our negatives and then add our positives. So we'll go ahead and do that. So if we add 4 and 5 together, we'll have 9, right? So we'll just give us -9. Okay. And then if we add our positives, then we have 10, right? So then we have +10. Then if we add those together, oops, +10. Right, so we have -9 + 10. So if you think of it in the old, and just in our last lesson, right, we said if the signs are different, then we can subtract them. So we do 10 - 9, and then we keep the sign from the largest absolute value, right? So 10 would be theirs. And this makes sense, right? So we have 1 and it'd be +1, right? This makes sense because -9 is not farther away from 0 than 10 is, okay? So that'd be how we do that one right there, right? Just our 3 simple steps up at the top. Okay, and then I don't think I have anything else to say here. Just I think if you want to work out your practice problems, pause the video and then come back to it and we'll move on to lesson 71. All right, so on to lesson 71 here. So let's go and open a tab here. So lesson 71, we're going to learn about powers of fractions and roots of fractions. So let's write that down. So 71, we have powers of, oops, my O there, powers of fractions and roots of fractions. So we've heard about powers before, right? So powers we've talked about before. If we had 2 raised to the 2, right, or to the second power, then we know that this just means that we have 2 times 2, right? And then that would just be equal to 4. So then if we were to describe something else, right? So I guess I'll just write an example here. So if we had example 1 here, we have 2/3, and this is raised to the 3rd power. Right, so then we're going to remember what these things mean, right? So this thing, what does this mean, right? This means how many times to multiply the number by itself, right? All right, so that this 3, right? This 3. So then that would mean that we can do 2/3 times 2/3 times 2/3. Okay, so that's one way to think of it. So then we do 2 times 2 times 2, right? Because we're just doing top times top, bottom times bottom. So then we'd have, we're going to write our equal sign here. So we have 8. And then on the bottom, we have 3 times 3, which is 9. Then 9 times 3, so we have 27. So we just have 8 over 27, okay? So that's our powers of fractions. Now, if we think of our roots of fractions, okay, we have a square root. Okay, so we might have talked about square roots, right? So this is roots, and it's still less than 71. So if we had something that was like this, this is 9, then we would know that this is equal to 3. So I guess one way you could say it is that this little bracket here is asking, oops, my pen here is asking what number can be multiplied twice to get to 9, right? So that's basically what this bracket right here means, right? So then it says, okay, what number can be multiplied twice to get to 9? And we just know it's 3. Now you can have it a little bit more complicated here. So we have, for example, 2. It's not too complicated, but if we have something that's 9 and it's over 16, this might look a little intimidating. But the cool thing is that it means the same thing as writing this right here. So you write square root of 9, and you write square root of 16 like this. Okay, so now we can use what we just learned, right? So if we use that, then we could say, oh, we already know that this is 3. And this bottom one, can you guys think of a number that you can multiply twice to get to 16? All right, so it's 4. So it's just 3 over 4. Now, if you can use one of these numbers, this right here is called 9 and 16. These are called perfect squares. Okay, so this is perfect square, that's perfect square. So other examples of perfect squares. Right, so we already said 9, 16. Right, 4 would also be one of those, because that would be equal to 2. Maybe think of this one, right? You think of square root of 25, 2 over 5. So you can go on the list and you can just do even more, right? You could do square root 36, and that would be equal to 6. All right, so I think that's it for lesson 71. So if you guys want to, to review, right? We have powers of fractions and roots of fractions. If we looking at this power here, right? This exponent piece right here where it has the power, right? That's how many times you need to multiply the number by itself, so 2/3. And then over here, our roots, this little bracket just simply means what number can you find that can be multiplied twice to get to the number inside, right? So 9. All right, so if you want to pause this video, and then we'll go on to lesson 72. Okay, so lesson 72. Lesson 72 is graphing inequalities. So we talked about inequalities before. So equalities, right? So equality was like something like an equal sign, right? So we're very familiar with those. But if we're talking about inequalities, we're talking about these little things, right? So if you have one of these or one of these, so think of these. I would think of these as like a mouth, okay? So, right, so if someone's really hungry, they have their mouth open towards it. So then if you had something like, let's just put some values here. So if you had 9 over here, and you had 8, right? 9 is obviously bigger than 8, so that mouth is going to eat 8. And then similarly, if you had 1 over here, and you had 3 over here, the mouth is going to want to eat the 3. All right, so then there's also other inequalities that involve just variables as well. So let's go for a couple steps to graph. So if we want to graph, a couple steps we want to follow here. So graph. First, we want to find the boundary. So we'd say find boundary. Okay, and then this other thing is called inclusion. So you have to decide on inclusion. So there's the ones that are described before, right? So if I used, oops, sorry about that. Okay, so if I used this one, or I used this one, these are, we'd graph those and we use an open circle. Okay, so we'd use an open circle. But if we used something like this or like this, okay, this bottom piece right here, oops, let's see here. This bottom piece right there means or equal. Okay, that means break this same one right here. So usually we'd say this top one right here, we'd say this is a less than, we'd say this, well, here, so we'd say that one is less than, we'd say this one is greater than, right? So if I was going to go back and read my 9 and 8 right here, I'd say 9 is greater than 8. And then for this one down here, I'd say 1 is less than 3. Now, if I use these inequalities with the lines under them, and then I have to say less than or greater to, or I say less than or equal to, sorry, I'd say less than or equal to, or I'd say greater than or equal to. All right, so then if I'm going to look at my third step here, so my third step is then just to identify the direction. Okay, so identify direction. Let's open a tab and let's look at one of these. So I have example 1 here. I have x is greater than 2, right? So that's how I read that one, right? Because the x is trying to be eaten by the mouth there. So then if I'm going to do my line here, right? And so like I said, always start your number line that's favorable to you. So 2, I could put somewhere here in the middle maybe, right? So then I just put 2 here. Let's put 1. Let's put 0 over here. Not quite to scale, but anyway. So this is 1. This is 2, right? And I have 3, 4. So let's just graph that. Now I want to identify the boundary, right? So I'm starting at 2, and then I said I need to decide on inclusion, right? So if we go back over here, right, it's an open circle, right? If it's one of these, and then I didn't draw this one right here, but this is a closed circle. Okay, so I'll write that down there. So closed circle. So just put in your notes there, right? So then going back here, right? It's an open circle at 2, right? So then I can write an open circle there. And then now if I read this thing again, right, it'd say x is greater than 2. So if x is greater than 2, then I have to go to the right, correct? Right? So then I could draw an arrow like that. So that x could be any value that's greater than 2, right? It doesn't include the value of 2 itself. Now, if I had example 2 here, this one said that x is this right here. So then let's think about how we read this, right? 2 is, we'd say that the mouth is going towards the greater value, right? So I'd say x is less than, but then since it has this line underneath it, I'd say less than or equal to 2. Okay, so now let's figure out my graph here. So I'll put 2, 1, 0 again, and then I'll put 3, 4. Okay, and my line is not very to scale here. I can put it better. 1, 2 here. This pen, it doesn't always work out the best. So anyway, so 0, 1, 2, 3, 4. Okay, and then I said x is less than or equal to 2, right? So now I got to determine my inclusion, right? So now I would put here and I fill in my circle because it includes 2. But then this time it's x is less than 2, less than or equal to. So then in this case, right, then my arrow is going to go just in the other direction. Okay, so then let me just think of one more example here. So if we had x, let's do a negative. So we'd say this right here. So if I was going to read this, think about how we read the last example. Right, we read the last example as x is less than or equal to 2. So in this case, we'd read it a similar way, right? We'd say x is less than or equal to minus 4. So I'm going to make our chart again, or our number line. So minus 4 is now where we need to start, right? So do -4, and do -3, -2, -1, 0, right? It's always nice to have a 0 on there. So -4, -5, -6. Okay, so it's -6 here. Okay, so now I got to figure out if my symbol is included, and have a non-open circle, right? It has to be closed because it's including -4, and then x is less than or equal to -4, right? So less than -4 is going to be more negative, so then my symbol or my arrow is going to go in that direction. Okay, and I think that's it that I want to cover. This is lesson 72. So that's all I want to cover for lesson 72. So a little bit of review on all of our lessons, right? So we did week 19 supplement. We had our true, false, conditional equations, and we had some examples of those. And then for 69, we're adding our assigned numbers. We can add them on a number line and move using our next numbers. And then in 70, we're adding assigned numbers more than one, right? And in 71, our powers are fractions and roots of functions are roots, right? We learned about our perfect squares as well. And then the last one, we're graphing our inequalities. So I think that's it. And I'll talk to you guys later. And if you have any questions, don't hesitate to email me or anything like that. Okay, and then the tutor session will be on Friday if you have questions to ask then. Bye.